We'll call this meeting of the Water Quality Management Committee to order. Chairman is on vacation this week, and so is another member, and I'm hoping the remaining member will show up. We're very fortunate today to have the U.S. Geological Survey be making a presentation. They have been working in many places all over the Cape for decades, and we're very fortunate to see Dennis LeBlanc, who's sort of the person that I met 50 years ago, probably. And our presenter today is Tim McCaw, who's doing the actual work in Mara Vista. It's very important for the town to know what the existing groundwater conditions are as it emerges into Little Pond and Great Pond, and to see the effects of the sewer installation as it goes through. So Tim has been doing all of that work, and I'm going to turn it over to you, and we're looking forward to hering about this.
Well, thank you very much, and thank you to the committee for making some room on your busy agenda to have us here today. I'd like to, first of all, my name is Tim McCaw. I'm a hydrologist with the USGS New England Water Science Center. This project here has been ongoing for the last 2 years or so. It started in May of 2016, looking at the water quality beneath one of these densely developed coastal neighborhoods, one that's going from conversion to on-site septic to municipal sewering. This work has been done in collaboration with the EPA Region 1, as well as EPA's Office of Research and Development out of Cincinnati, Ohio. The primary funding source for this project has been the EPA SNEP program, the Southeast Coastal Watershed Restoration Program. We've also had some cooperative funds from the USGS, as well as some funding from the EPA ORD, Office of Research and Development. So the project objective in general is to establish a monitoring network in a typical coastal neighborhood, one of these densely developed neighborhoods, to assess baseline water quality in hydrologic conditions to evaluate the impacts of sewering on the reduction of nutrient loads to the coastal ponds. So we all know that putting in the sewer system will ultimately greatly reduce the loads to the ponds. But what we don't really have a good understanding is what does the distribution of nitrogen look like under these coastal neighborhoods? And can we take this opportunity to kind of evaluate that and put it in, particularly the time frame that we're talking about here for the cleanup to take place? So our study questions are, what is the spatial and temporal distribution of nitrogen in groundwater below one of these typical coastal neighborhoods? As you see here from my diagram, we all know that ammonia is oxidized and then it reaches the groundwater as nitrate. And the question is, what does this nitrate pool look like? Does it coalesce into one large area of elevated nitrate? Are there individual plumelets that develop? What does the temporal effects of the loading and the seasonal residents, how does that affect the loads? Do we see pulses? All getting at this question of what does it look like as it approaches and discharges to the coastal receptors. After sewering, how long until the nutrient loads to these receptors decrease? That's the big question, is how long do we have to wait?
Yeah.
Now that these sewer systems are going in, how long is it going to take until we see these changes occur? What metrics can be developed to assess these changes? How do we want to look at this over time? What's the best way to look at this over time? Are there indicators of nitrogen loss in the system before it gets to these receptors? And then this has been an add-on where what is the occurrence of these emerging contaminants or contaminants of emerging concern, also known as CECs, from downgrading of on-site wastewater systems. So these have been extensively studied in wastewater systems on river systems, downgrading and upgrading of wastewater treatment plants, but there hasn't been a lot of work at looking at downgrading of these on-site systems. So we're hoping our network could also shed some light on that as well. So just as a little refresher, I know the committee knows this well. On the left here, we see the MEP Groundwater Watershed. This is developed actually from USGS flow models. The watershed for Little Pond extends to the northwest here, and these green dots represent wastewater flow for each of the parcels. And this all comes from the Cape Cod Commission's Watershed MVP website. These are So what happens here is any wastewater or precipitation that hits the ground in this area recharges the system and ultimately makes it to Little Pond. If you look at the Mara Vista side of this delineation, you see it's a pretty straight line north to south. It's almost just drawn in there as a straight line because it's pretty unclear of where that delineation is. We know that on the west side there, flow goes towards Little Pond, and on the east side we have groundwater flow towards Great Pond. On the right side here, I have a water table map from the late 80s from Millam and Howes, and it shows what you see is you have the water table, you have high gradients, hydraulic gradients near the heads of these ponds and rivers, but as you move down these coastal necks, you see that it flattens out quite a bit till you get very low gradient conditions, slow flow conditions. The red box there that I show you there on the right side on Mara Vista Peninsula is where we chose to focus our study area for a couple of reasons. Number one, it had the highest housing density that we were looking for. Number two, we were hoping for some shorter flow paths to see some changes pretty quickly and not be up in the regional system where you have these longer flow paths. As well as working in the Mara Vista Peninsula gave us an extra year based on the project timeline. So we needed that extra year to get our sites in. So in May of 2016, we set out with a geoprobe drilling rig. And at 14 locations, we put in what's called a multi-level sampler. These are 15 sampling tubes that extend down to different depths in the system. Our goal here was to limit the number of sites that we had in groundwater. We really wanted to focus these sampling sites in the freshwater zone. Also at these sites, we put in a 2-inch monitoring well at the water table to measure hydraulic gradients, heads. And at 4 locations, we put in deeper wells to look at vertical hydraulic gradients. On top of the installation of wells, we also cored at 4 locations, and I'll show you those results in a moment. And as well, we have a 15th site that's on Seacoast shores that we use as our reference multi-level sampler that we return to for each sampling round. And that's presumed to be a site that there's no plans currently for sewering. So here's our Mara Vista study area. Our study area in general extends from Cedar Street down to about Providence Street, or a little north of Providence Street. The study area covers about 225 homes, although we know that the contribution of groundwater also comes from the north from this map here too. It's reported that greater than 50% of these homes are still on cesspools, but they're now being converted, obviously. And based on water use, about 40% of these use less than 50 gallons per day. So what that tells us is we have a lot of weekend use homes, seasonal homes, and these are second homes for a lot of people. So there's a real mixture of the water use. Also, based on water use, you can also look at the loss of return flow, assuming some consumptive loss. We're talking about once the sewering goes into place, we're losing about 5 inches per year of recharge to the system. It's not a huge amount, but it's something that we want to consider and keep an eye on when we look at hydraulic gradients. So our monitoring network consists of these blue and red dots. All sites here, are the blue and or red, have multi-level samplers in a water table well. The red sites have the deeper well in the system for hydraulic monitoring, head monitoring. The X locations are where we collected our seepage meters. Where we collected our sediment cores, here, and here. Early in the project, in March of 2016, we put in some temporary tide gauges at Little Pond and Great Pond to see how the tides, how they responded, and how they looked on average between the two to see if there was a hydraulic gradient between the two ponds. It seemed to be pretty flat. And those means there become the baseline for our system as we look at hydraulic gradients. The blue lines you see here are water table contours. And like I said, this area is very flat. It's only 1.4 feet here up at the north, down to about 1.1 feet. You see, if you look at this closely, a groundwater divide sets up here along this line here, where flow to the west heads towards Little Pond, flow to the right heads to the east heads to Great Pond. And that's what I was going to say about that. Let's see.
How do you determine which way it's going?
We have a few different ways. We can triangulate 3 wells to look at gradient directions. We can also just look at the contours and draw perpendicular lines to get a good idea which way it's going.
Thank you, sorry.
No, it's okay.
So I added this in here, sewer connections in the study area as of August 30th, just a few weeks ago. This data was provided by Kyle Swanstrom. This shows the purple here are the sites that are now connected. The yellow is not connected as of yet. So between Cedar Street and Providence, there's 200 properties, and of which 133 have now connected, or at least at the end of the month there. So that's about 55%. So I look at this in where do they fall in proximity of our wells, and we still have quite a bit of gaps up gradient that we're looking forward to these homes getting connected so we can really start the time clock here. So the freshwater thickness, we can determine this based on specific conductance through these detailed profiles. Freshwater conductance here ranges from about 30 feet up in the Iroquois Street area down to about 10 feet along both shorelines. And this reflects where you have a higher water table, you have a thicker freshwater thickness based on the difference in densities. Where you have higher head, you have a thicker zone, freshwater zone. So on average, we're at about 18 feet of fresh water here where all these homes are contributing to. So I'm now going to show you some profiles from west to east here for AA prime. And then these red circles are where we collected our sediment cores. Here's our transect from west to east. This green line here is our land surface. The blue line, light blue line, is the water table, and then this red line here is delineated. That's the freshwater saltwater interface. What we found in those profiles of specific conductance, the interface was pretty sharp, occurring over less than 5 feet, or usually about 2 to 3 feet, where it quickly changes over to saltwater. And we really consider not much mixing to occur between these two zones. So we really focused our study on the freshwater zone and what's going on in that region there. So you have this lens of freshwater sitting on top of this salt water. If you look at the core locations here, the green colors represent medium to coarse sands. For the most part, that's what we saw throughout at all the locations. As we got a little deeper, we did see some fine sands in the middle here at F760 at Reynolds Street, and then some at the south site here. A little bit of fine sand, but no silts or clays that are really going to control the system, so we were happy to see that. So using those cores as well as our head measurements, we can develop these or create these simple 3D flow models, a mod flow model based on those field observations. The model incorporates the flow system geometry, the boundaries, the shorelines, recharge, our observed head measurements and gradients, as well as the mean tides. And from that, we can do some forward particle tracking to simulate travel times. And so what we do is we put a particle at the water table. We do it for every cell in the model. We run those forward until they get to these receptors, and that's where they stop. From that, we can get a travel time, and in general, distance from shore dictates travel time. What I've shown here is two flow paths that in map view follow along the same path. One starts near the center of the peninsula, where the other one's about halfway to the shore. But they look like they follow the same path in map view, but if you look in a cross-section, they're quite different in time and age. This closer path here is about 2 years, whereas if you move into the middle of the peninsula, you're talking about 7 years. And when you map these in map view, you can get this mosaic of all these different these travel times. And what we see at the center of the peninsula here, along this center, you get times as great as 10 to 12 years travel time, and that's conservative travel, one flush to the receptor. So it really does depend on where in the system you're starting your recharge from. So our mean travel time through the system was about 2.5 years, where the majority of the properties that are along the shoreline all fall into that 1 to 2 year time frame, all along this outer shell. And then, like I said, the max were a little bit greater than 10 years. So our sampling scheduled to date, and this is a list of analytes that we've collected to date. Our wells were installed in May of 2016. We're happy to report we've had 2 full sampling of all 230 or so well screens on 3 occasions, June 16, April of 17, and then just this past April of 18. Those full sampling rounds include a full suite of looking at nutrients, nitrogen, nitrate, nitrite, as well as ammonia. Each round is a little different. In the original round, we looked at things like boron and chloride. In cations, we've added some major ion analysis for some of these partial rounds. So it's a little bit different in each round, but all along we're also doing these bi-monthly sampling at 2 locations. So we want to get temporal trends by looking at changes over time. So we've repeated samples bi-monthly for the first year or so. We've now converted over to this quarterly sampling. We just had a quarterly sampling round a few weeks ago, and we're waiting on the lab results for that. That was back in late August. Our next quarterly sampling round is for December. Looking forward, we have the connection deadline, which of course you guys know about in 2019 spring. We have a full sampling round of all sites in February, where we want to do this during the winter months, as opposed to always sampling when it's beautiful outside. And then we have 2 more full sampling, and we're trying to really push these off into the future as far as we can, given that we know these changes are going to take quite a while.
Good.
So I'll leave it at that. So going back to our section AA prime, this is along Reynolds Street. Here's 4 multi-level sampler locations. I'll now show you what we see in these geochemical profiles. So here's an example of 4 geochemical profiles. I'll walk you through these here. The green zone here is specific conductance greater than 3,000 microsiemens per centimeter. So if you look across that here, we can see that freshwater, saltwater lens through these 4 sites sitting there. The blue line here is the specific inductance. You can see that sharp break between fresh and salt water. The dashed line you see here is dissolved oxygen from 0 to 10 milligrams per liter. What you see at the water table is highly oxygenated water right at the water table, and as you get down into the system, you quickly get to suboxic or anoxic conditions as you get into the sewage contaminated zone or sewage plume. The green line here is nitrate. The scale here is 0 to 25 milligrams per liter as N. This site here in the original, this is the June 16 sampling, we saw as great as 18 milligrams per liter as nitrate at this site here. In all cases, we see elevated nitrate in the system at all 14 locations, and it tends to occur deeper in the system, in the deeper half of the system, and that kind of has boggled us to why don't we see much nitrate in the shallow zone. There's been a few theories that it's probably, and it's most likely related to your distance from the source. So if you're right down gradient of a source, you can, like in this case here, we see this peak only 1 or 2 feet below the water table. This deeper zone of nitrate here is most likely from further up gradient, or it has to be from further up gradient. And then there's always that question of, was there nitrate here and is there a loss? Is there indications of nitrification or any other processes that could be removing nitrate? And that doesn't seem to be the case. Maybe at this site, but I'll talk about that in a minute. So as I flick forward here, this is June 16, and now I show you this orange line, which is also nitrate. This is our latest in April of 2018. You see that maybe at 2 of these sites, it's dropped down quite a bit, or maybe halfway. But at this site here, it's jumped up as great as 24 milligrams per liter. And then this one here seems to be generally following the same pattern that we saw back in April, or back in the original June 16. So there's quite a bit of variability in the system. We see these jumping back and forth with the seasons, and we're hoping that the temporal sampling will shed some light on what's going on there. So I wanted to show the Seacoast Shore site is located on the west side of Bayside Drive. It's a site it's a multi-level site that we use as our reference condition here for the Mara Vista study. And it's remarkable when you look at this nitrate profile. It looks very similar to that high one that we have on Reynolds. at Mara Vista. This site here was part of a study that was done by Coleman and others back in 2013 and 14, and it's just been published as of this morning. This link is live as this morning. So this is a study that looked at the nitrogen transport near shore at the Eel River on the west side of that peninsula, and got into the subterranean estuary there, looking at discharge. So we'll continue to go back to this site here. Their study did show that there was some loss of nitrogen in the shallow zone here where you had the carbon to support it. There was some denitrification, or at least production of dissolved gases. They did not indicate any loss down deep here, not until you get to the saltwater zone right at the interface there. But it's remarkable how similar it is to the Mara Vista site. So going back to Mara Vista and our full map view here, there's a lot of numbers here, but just to explain that the bottom number is maximum concentration of nitrate. The top number is a average concentration. So we take these detailed vertical profiles and we integrate them and depth weight them and get an average only in the freshwater zone here. So that's a better way to look at than to just look at these maximums all the time. So if you look at through here, it's pretty consistent on the east side. These averages run about 6 milligrams per liter, 6 to 8 on the Great Pond side. On the west side, on the west side here, we have about 4 to 5. And then, as I pointed out before, the maximum here, the max site here was at this 760 here on Reynolds, where we had 18 and now 24 in the latest. So we have, significant nitrate at every site. This one here only had one port, I believe, that had nitrate, but that's where the freshwater zone is super thin as it starts to approach the pond, the salt pond. So I'm also now going to show you some temporal plots from this site here, F760, and this site here on Narragansett, F767. These are the ones that we continue to repeat sample. We've done them 9 times at this point, first bi-monthly and then quarterly. So here's 767 in red, and here's 760 in blue. And then I show the maximum concentration in the profile as well as these profile averages. And so what you see is, number one, we're not seeing any decrease in May of 18, even with some of the connections being made. It looks to be pretty steady and actually trending upward. But for the most part, you see some variability over time, but it's pretty steady. For 767, we're somewhere between 6 and 8 milligrams per liter. Max in 3 to 5 on average, and then this other site is much higher, 10 to 14 or so on average, with that max of about 25. So we'll continue to look at these over time to see when we may have some indication that things are starting to change. So this is really changing gears here, but as part of our work with the EPA Office of Research and Development, they had interest in also sampling from these wells to look at things like contaminants of emerging concerns, or CEC, things like pharmaceuticals and personal care products, perfluorinated compounds, hormones, bacteria, as well as sucralose, the artificial sweetener. And so they've been a part of the sampling rounds, a subset of the sampling rounds for all 3 of the full ones that we've done to date. And then just to show you an example of some of the things that we see for pharmaceuticals and personal care products, out of 135 or so analytes, these 19 or so were detected. This was in September of 16. So of 32 samples that they collected, I show here in parentheses how many times each of these compounds were detected. So we have lidocaine at 21 of 32 samples, sulfamethoxazole, which is a common antibiotic, 18 of 32 samples, Sudafed of 14, and then you go down the list, we have pain medication, heart medication, a little bit of nicotine and caffeine. And so I should also mention, these are at parts per trillion levels. The instruments are amazing now at what they can see. These are at parts per trillion, and these are not atypical of what's seen across the country at this point. They're doing a lot of these studies, and they almost always see lidocaine and sulfamethoxazole, SMX, as 1 and 2 at the top of the list for frequency. So they're really looking at frequency of these things and how they occur in the environment. So I always make a joke, we have a bunch of folks that are going to the beach too much and getting sunburn and need their lidocaine, as well as their pain medications and everything else. So I will leave it at that. Another thing that we're looking at is with our work with that group is sucralose as an indicator of wastewater. And now sucralose is in almost all the is Splenda. It's in almost many of the diet drinks, diet sodas, low calorie or no calorie drinks. It's passed right through the system. That's what makes it no calorie. It doesn't break down, and so it's a very good indicator of wastewater. And if you look at in the vertical, these are the blue bars here of sucralose compared to total nitrogen, it's a very strong correlation between total nitrogen and sucralose. So this was detected in 27 of 32 of those original samples and 14 of 15 of the April 17 samples. So it's everywhere at concentrations up to 27 micrograms per liter or parts per billion. So it's something we hope to keep looking at. So as we start to see decreases in nitrogen, we can also look at sucralose to see how that's changing as well as an indicator. So back to our schedule here. Like I said, in the future, we have a full sampling planned for February, and then October of 19, and then September of 20. That's at the end of the fiscal year. We're really trying to push these things off into the future, given the time frame that we expect. Like I said, the next quarterly sampling is in December. So the products from this study are number one, a USGS data release, which is just about ready. It's up to through August, our August sampling round, and that will then be linked to a project web page where we can host these profiles. We want to have these geochemical profiles available. There'll be a link to the data release, as well as a site map in all of these profiles that we can show over time. So the thought is, as we go out and make these sampling rounds, we can keep that website updated so people can be aware of what's changing and how it's changing. And then ultimately, we're working on a USGS SIR scientific investigation report to document the network and document the changes over time. And so that's all I had for you.
Okay, well, that's a lot. Questions? Matt, I heard you taking a lot of notes.
I do. I have about 6 or 7. Is that you can cut
Well,
me off whenever?
start with a couple, and then
Yeah.
we'll move to Ron, and then we come back.
Sounds good. I have a gut feeling that this probably isn't important, but are water inputs from the septic systems and irrigation, do they have an effect on the water table elevation and the hydraulic gradients?
Well, like I said, we estimate about 5 inches per year of recharge will be removed from the system. So
Okay.
it could be measurable in gradients. It's probably very difficult to notice that if just looking at hydrographs. We've done quite a bit of water level monitoring, and it may be hard to see that difference.
About 12% then, roughly.
But yeah, a little more than that. I
Little
think
more than that?
some are like almost as much as 20.
So
20%.
Yeah.
So those travel times might actually
Slow.
increase. Yeah.
Okay.
And do you have a rough idea of what the flow rates are, the horizontal flow rates?
Yeah, that's a great question. I think it's about a third of what we see to the north. So I think it's about a half a foot per year.
Okay.
But I can get back to you. Per day.
Per
yeah,
day,
not per
yeah.
year. Thanks.
And then maybe just one more for now.
Yeah.
I was interested in the variability of the nitrate with depth, and yeah, maybe you can pull that up.
Sure.
You know, the lower values near the surface. You know, if you were getting removal near the surface of nitrate, and then what you're seeing down at depth is nitrate from the surface just at a further afield location.
Right.
You know, you would expect removal in that older groundwater as well, unless it maybe started with a much higher nitrate concentration. at that
It's my
location.
understanding that it really depends on the carbon that's available in the system to push something like denitrification to
Right.
happen. So,
Yeah, it's
Dennis?
Can you speak into the microphone? That way, everybody at home will be able to hear you as well. Okay, here we go.
I don't know if I
This is
answered.
Dennis LeBlanc. USGS?
I just wanted to point out the report that went live this morning has a tortured discussion of all the possibilities of why that is the way it is without a conclusion. Like, we're not quite sure. So if you want to get more thinking about that, there are hypotheses that are put forward to try to explain why that pattern looks the
Okay.
way it does. And so that's all I wanted to say.
So many of these houses are seasonally occupied, right? I mean,
Right.
would you expect to see, seasonal pulses in nitrate passing by? To get to your point of the next slide where you saw the seasonal
Yeah, I
variability
think
at
we do,
depth seems
we do
surprising.
see that if you look in the vertical profiles and you line those up to each other, you see this coming and going quite a bit in the vertical. So, yeah, I think we do see it. It's hard to tell as you get deeper in the system if we're talking about, 2 years away, 3 years away, how many streets away. It's usually not that near system.
Okay.
So it's hard to say where it's
And then maybe just one last question
This is the last.
for now. Okay. So, sticking with the attenuation topic, can you make an estimate of that based on the inventories? I mean, you have such a rich set of data spatially, looking at nitrate inland versus nitrate at the coast and knowing where the water is coming from. Could you say something about?
Well, that
Attenuation?
report that Dennis mentions does get into discussion of that attenuation, if I'm correct, right, Dennis? Yeah. So I'm not sure of the exact rates they're talking about for attenuation. So no, I couldn't answer that.
Ron?
Well, thanks, yeah. To follow on this topic, as we look at the freshwater lands, it gets very thin at the shore.
Correct.
And the nitrogen levels are also lower in that range. The nitrate levels are lower at that point. So the question I have is that because that the depth there, basically where you're measuring, is getting very shallow, basically, as you approach the shore, there could be a lot of denitrification going on at that aerobic airobik
Correct.
And, but then the question comes in is that as the water flows out, there's a pretty good velocity right at the edge because it's narrow and it's got to get out,
Increasing,
right?
yes.
Because whatever comes in's got to go out.
Right.
So you need to multiply, in a simplistic way, at least the volume versus the concentration to find out how much nitrate is actually going in the
Right.
pond, and not just the concentrations, because there might be a rather large impact through denitrification. But still, you have a relatively, you'll have the
Right.
larger volume passing that transect. So I just wondered about
We
that.
do have, we have talked and we did plan on doing some flux calculations across the boundary, at least for where we have sites.
Uh-huh.
On this eastern side, if you were to do a transect along the western side. Using the gradients that we've measured, it's not going to be as fast as you're talking about right at that interface where the system is thinning, the freshwater is thinning, and everything's speeding up, as you say.
Yeah.
But we are going to hope to do some flux estimates.
Because those wells are a little bit far from the edge, actually. I'm not sure how many
Right.
feet that is, but
Yeah.
as you get closer, it's going to get even narrower. And
Right.
there could be more activity going on.
Yeah, we
if there's
we
carbon.
kind of wanted to it came down to spatial distribution as well as available land, so.
Okay.
Yeah.
And I had just another question. Is it, we've been talking, although it's not so much of a concern with the saltwater ponds, but it's phosphorus removal in the soil. And I don't know if you have thought about doing any measurements just to see what happens to the phosphorus
Yeah.
in this context, because it's not really an issue for the saltwater ponds, but it is for some of the freshwater, and
Yeah,
it might
right.
be that we could get some indication of.
We did collect
absorption.
total phosphorus as well as orthophosphate
Oh, you
for
did?
some of these sites in the first sampling round, and we saw zeros across the board, so.
Zero
Zero
phosphorus.
Yeah,
across the board.
pretty much, yeah.
Oh,
pretty
that's
much.
good, okay,
Yes.
good. And-
It's strongly sorbed to the sediment, and it's probably not transporting.
And then the other, this is just an observation, which, on the validity, you said that it may take 10 to 12 years for the water from the middle of the peninsula to migrate out, right?
Right,
I mean, it's an interesting point in terms of the the state's estimate of the economic useful life of a sewer system, which is about 30 years. So, you know, it is an interesting economic dimension to it. And it doesn't mean the system's going to collapse after 30 years. It just means it's repairs and all this other stuff are going to start catching up after time. And the pipes may be there, they may be okay. But it's not a question, it's just an observation that putting it in that context, it makes the cost effectiveness aspect a question anyway.
Yeah. I mean, the benefit at these near shore will be almost immediate, you know, within the
Right.
first year to two. So you're going to get a big bang for your buck in those near shore right away as soon as they hook up.
Right.
It's just, you know, some of these longer flow paths will take a little bit longer.
Because if there is a denitrification factor over time too, that may be in the soil, that may be something that would be observed, which may better target interventions and where to go exactly. So, from an economic viewpoint and environmental as well.
Other questions?
Yeah.
Yep,
Okay.
Steve?
3 questions. Great talk, thank you.
Thank you.
There's no better illustration of how much variability and travel time is going to affect us. Do you have a rough estimate of what's the earliest year at which we would have statistical confidence that we're meeting the TMDL in Little Pond?
That's a tough question to answer. That's a good question.
You can put error bars around it, you don't have to give a single year.
And it may
50
not be
plus or
this
minus
meeting
50
that you
years.
give us the answer, but I think
Yeah,
it's an
I think we
interesting
need to do
question.
more of our sampling to get down the line before we can answer a question like that, yeah.
Right.
So,
And I'm not
Budget.
requiring accuracy, you know, I don't need it to the nearest month.
yeah, I don't know how you're
One other thing, only 80%, is about 88%, 86% of the wastewater inflow, of the sewage inflow is actually captured, so there's
Yeah.
still a lot of factors.
Yeah, and so that'll be another interesting thing, not only the timing, but where that background level is, how far back is it gonna go, and there will be some background level of nitrate.
But we all agree that would be a fascinating answer, right?
Yeah.
The second question is the sucralose is fascinating. Is it cheaper to assay for that than for nitrate?
It's still, the methods are still in development, so I would guess not. You know, nitrate's pretty cheap to.
So you might as well just assay for nitrate.
Yeah, go right to
Okay,
the,
all right.
nitrate.
It wasn't nitrate, it was total nitrogen that you,
For that, in
Sure.
that case, and of the total nitrogen, it's pretty much all nitrate.
But it isn't some magic cheap solution to lowering the cost of assay.
No, it's an element that doesn't degrade in the system that will be present in something that we can kind
And
of
then
lean
the
on.
last one is, you mentioned the parts per trillion concentrations of the CECs. How does that compare to the effluent from tertiary treatment plants?
That's another great question. That's something that I could pass along to the folks that do that kind of stuff
Because
regularly.
otherwise, unless you make a relative statement, it's meaningless to the
Yeah,
man in the street. You say, oh, there's this bad stuff there.
Yeah, and
If
what
it's
they're
also
doing is,
everywhere else, then so
they're looking
what?
at occurrence in how it compares as a whole, so, yeah, it's a good question, too.
Go ahead.
no,
I
go
was just
ahead.
gonna there have been other studies done on shellfish accumulation of a lot of those that long list you had. And they haven't found, at least in terms of the hydrophilic one, or is it hydrophobic? Well, one of them, that there hasn't been an accumulation in shellfish at least. Now, whether there's an impact on the ecosystem somehow otherwise, that's another question.
Just using this particular slide because it's up. If you remember back to one of your very early slides, which depicted the Little Pond watershed, and we knew that this straight line down Mara Vista was basically an
Right.
arbitrary line. It looks like actually somewhat more when you look at least at this
Yeah,
section.
it looks like it's shifted, it's
It looks
a little
like
bit to the west of
Somewhat
Maris.
more discharges to Great Pond than to Little Pond.
Yes.
And so ultimately, in terms of figuring out theoretically what's the load to Little Pond, it might be somewhat less. I just but that's what shows in this particular section of Mara Vista. Whether it's the same throughout the rest of the peninsula, we don't know. The other thing that I found really interesting was the one where, show where you, it's towards the end, where you have the saltwater and the freshwater, the 4 graphs that go across. There we go. You said that the actual interface is something like 2 to 3 feet, the difference between being in freshwater and then being in saltwater.
Right.
And I think that I was going to ask you, do you find that also at Seacoast Shores?
We did see that at Seacoast Shore. It was pretty abrupt, yeah.
Because when this committee originally hired an engineering company to look at the PRBs, the question of the saltwater freshwater interface came up. And it was postulated that it was like 15 feet. And that it was, a very
You look
broad
here,
area.
If you look here on the right, we have the conductance profile here in the blue.
Yeah. And so having this kind of specific information is very useful to get a reality check, I guess, on
Yeah,
that
now looking at
initial assumption.
Seacoast Shores, it's probably around 5 to 10 feet. It's a wider peninsula, a bigger freshwater lens
But
because
if
of
you,
that.
if you look at the curve of specific conductance, the blue curve,
Yeah,
you get a much more diffuse feeling than if you look at the line that somebody drew between aquamarine and white.
right.
It's also
That's-
log scale, too.
Yeah, it's log scale,
Always.
so
It's
we're
log scale.
I see.
So, I mean,
about
someone
200.
Yes, I
picked
see.
a point, and by
Someone picked a
definition,
point.
they didn't have a felt tip pen that was half white and half blue and shaded it in.
Right,
They
that's,
just drew a line.
I see your
But if
point.
you look at the actual graph,
Yeah,
Right.
blue.
Right.
very good, right.
It's a
All right.
vertical.
Are there any questions from the audience? Matt, do you have any more follow-up? John?
One of the things that struck me, I think there's been some recent data that looked like in some of these peninsulas, the groundwater was not being so driven by the north-south flow, but when you got out on these peninsulas, that it became an east-west flow pattern. But what you're showing here is there's still a lot of north-south
At this location?
at this location.
At this location, right?
Not so much.
And I think
Yeah.
as you move down into the southern part of the peninsulas, you really get this flatter system where you may have more lateral flow and less.
But there's still here, at this point, an impact from the greater lens flow north-south.
Yes, yeah. A lot of the regional flow peels off to the headwaters here of the pond and the streams above. So we're hoping that most of that regional flow is peeled off here, and we're looking at more local flow paths or shorter flow paths.
Well, we would certainly like to see you back in a year when all of that turns to pink. And
We look forward
had
to
a
it, yeah.
couple more rounds of data. This is extremely helpful. Thank you
Good.
very much. Oh, Doug Brown, Selectman?
Hi, Doug Brown. So it looks like you probably will have overall data for the overall water heights, because it's understanding that when the sea level rise, it's going to push the water table up. So you'll be keeping track of that too for us?
We do intermittent water levels when we visit to sample. And in the early stages of the project, we put in some pressure transducers where we looked at longer term, on the month scale, continuous. So, yeah, we are documenting the water levels as well.
Yeah, sure. See?
I just want to point one thing out about the north-south versus east-west. It's really complicated. If you look in the upper right of that picture that's up there now, I would say that's predominantly, on the right half,
Right.
predominantly flow east and west.
I agree with you.
Yeah.
And then, and you go further south, it actually looks like more north to south.
It depends on the where.
It depends on your metric of it. I mean, it's complicated.
Yeah.
There was another slide you had with arrows on it that showed
Flow paths.
the flow paths, the early one,
This one, yeah.
that one, yeah.
Yes, but that's early,
That's coming in, that's not
That's
the
coming in.
peninsula. That's
right,
coming
not
in.
going out.
Yeah.
So when I look, our flow model extends all the way down the peninsula, and what you get are these little islands or little lenses. so you have these lateral flow paths at the middle of the lens and then the north-south on the ends. So yeah, if we were to extend this would, you're right, there's a lot of lateral flow as well. So you have these little mounds.
If you had it to do over, would you pick any other location in Mara Vista to do this density of wells? Or do you think you've got a pretty typical section?
I think we have a pretty good section, yeah. I'm happy with the way it's going so far. We've struggled with how we were gonna set the network up, or did we wanna spread these out on both sides of the pond? Do we wanna focus just at the shoreline? Did we wanna, really spread them out all over and do, as well as the south? But I think by keeping these all together, condensed and compact, we can start to see changes that kind of tie together and make a little more
Could I
sense.
ask one more
And
question?
if I could just follow up, and within this area that you're monitoring so closely, you said it was about 200 houses? Is
About 225, just the
225?
footprint, yeah.
Okay, footprint.
Not the
Okay.
groundwater footprint, but the
So-
footprint, yeah.
I had a question. We're talking now about having about a 10-year timeline to be able to see the system flush itself out,
Totally,
totally.
or at least
So
Flush
the
once.
question I had was, will those wells have a serviceable lifetime to work over that 10-year period? And are we going to try and push that sampling all the way through to what we think will be?
Yeah, that's another good question. The wells will withstand the test of time for quite a while, yeah. We have some now that LeBlanc has been using for 30 years that are holding up pretty well. Although some of these tubings do get brittle over time and start to break. But yeah, we're hoping that we can keep this going in the future beyond 2020, obviously.
Well, if you have a fixed pot of money, and subject to what you just said about the tubes breaking up, it would make more sense to have less frequent monitoring over more years than very frequent. I mean, you have to decide what the optimum
Right,
trade-off is
there's so
for a
many ways
fixed
to balance
pot
it.
of money.
We really, I think that the temporal sampling's very important at a couple key locations to monitor those over time. But these full snapshots also tell you what's going on in some of these other locations that you're not sampling so frequently, so.
And the other thing is ultimately, if you select just some key parameters that you want to measure rather than the full suite,
Right.
that's another
That can
way.
keep the
And
cost
I
down.
think that this committee and the town would be well-served by viewing what happens after 2020, let's say the next 5 years or 7 years in that, to have some sort of discussion about a plan, even if, maybe the town participates. Because it is an ideal site, it's reality, and it will provide the town with a great deal of useful information about all of the effort we're making on
Right,
sewers.
and we're hopeful that these other coastal communities can use this as a demonstration of what are you talking about when you make this decision, or looking at these other alternatives?
Yeah.
How much time are you talking about? And so we're hoping that this project can demonstrate that over a longer term.
Thank you. Thank you very much. If there are no other questions, we'll move on to the next agenda item. Thank you, Tim.
You're welcome.
Dennis, nice to see you.
Good luck.
All right, the next item on our agenda was a discussion and vote to revise the final report, diagnostic assessment of nutrient cycling in Mill Pond. This is in East Falmouth. It was submitted to us by Amber Unruh and Brian Howes, who had made a presentation to the East Falmouth Village Association, and they've now would like our committee's input and approval so that they can finalize the report. There were a few minor typos and errors of that sort, but we have not actually, because of time at our last meeting, didn't discuss the recommendations, of which there were 3. And so I'm here, so it's on the agenda for today. Does anybody sort of out the gate have any comments?
I mean, I unfortunately was not able to attend their presentation in East Falmouth, so the report was the first time that I'd seen their
Okay.
results. And I do have some comments for them, mainly about the sediment removal
Okay.
term of nitrogen and phosphorus. I don't know if it's appropriate for me to just talk to them directly about that, or if we
Okay.
need to discuss it here. And
I think that usually that kind of technical discussion is best done directly. For the report as a report, do you see that in any way as being an obstacle to approving the report as presented?
I don't think so.
Okay, all right. John, do you have any
No, I don't.
comments on that?
I have a comment, but I'm
Okay,
perfectly happy to accept the report.
okay. Make your comment and,
Or it just is, it's not, well, I'll tell you what it is. One of the suggestions was harvesting plant growth and
Yes.
possibly algae. Then, which I've heard of in other contexts. And maybe it wasn't in this report, it doesn't, but
Wasn't.
they do get an algae bloom there. I mean, that's
Yes.
why the neighbors are complaining.
well, go ahead.
And the similar complaint was in Perch Pond.
Okay, then I do have to correct you. The major problem in Mill Pond, there is some algae there, but
Right.
the major problem was macrophytes, large vegetation.
Pond lilies and
Pond lilies and things, that totally, the pond used to be open, and now it is
You're right,
totally
you're right.
choked with very vascular plants that are definitely are subject to, or could be harvested if there was a decision to do that.
Okay,
It's not micro, it's not,
good point.
little
good
floating
point.
things.
But I'll still make my comment.
Okay.
All right, so the plant life is different, substantially different.
yes,
But in both cases, you have an acute problem that none of our long-term solutions is going to fix in the next 5 years, or maybe longer.
well, certainly in the next 5 years, okay, finish.
There is commercial technology for harvesting this stuff.
Yes, there is.
The more you need to harvest, the more economical it is to rent or purchase equipment and set up programs to do it. Especially, you can share it with other communities on the Cape.
Right. Okay, that's your
The-
comment.
Yes.
Yes. In these 3 recommendations, the first one had to do, that they felt that the first effort should be the aquatic vegetation, but they also brought in the matter that part of it is debris coming down the stream from the cranberry bogs
Right.
to the
Yeah,
north.
yeah, no, there are other solutions. I'm just saying
Okay,
that,
and those can be acted on fairly immediately is where I was
Right.
going with this comment.
well, and maybe this only applies to Perch Pond, especially there
to
because
Mill
they were
Pond.
willing to use private money, I believe.
Mill Pond,
Perch Pond was
Perch
willing
Pond.
to use private money too.
That's true, okay.
And I'm just saying that people should, I would be interested in the comments from people like Ron and Tom Duncan, if you were here,
Yeah,
who may know more about this than I do, about the feasibility of them renting a boat with a harvester. I mean, it's a different kind of aquaculture.
right. I think it's something we should look into. Tom Duncan was not able to be here today, but he said he didn't have any, he had no edits or changes or recommendations to the report. Ron, did you want to make any comments on Mill Pond?
Right, well, we were just talking about Perch
Well,
Pond.
I digress to
Oh,
Perch. You
okay,
can come
all
back
right,
to Mill,
good, sorry,
of course.
I had to jump out for a minute.
Yes.
Yeah, I was just gonna suggest that, that we suggest to the research team that they might wanna consider yet another recommendation. And, that would be following on the current, Coonamessett River Restoration Project, which is revamping the river to get it into more of a natural condition as a habitat as well as a denitrifying element to some extent. I mean, it's limited in a way. So, the one question is, which would have to be discussed with the neighbors, of course, and it's a big suggestion. I mean, it's big in terms of what needs to be considered. And that would be possibly, because a mill pond is an artificial pond, it is like, it's a tank with a dam, which is essentially at Route 28. And that if it were returned to a wetland, those issues over the pond would go away with the pond to some extent, and that the wetland would then function as a nutrient mitigator or attenuator. But it would change the environment. It would look more like the bog or wetland kind of thing. It'd be very different from where it is today, which is what the neighborhood is interested in preserving. And so, but so I was just thinking that would be another option that hadn't been in the list. I think there was, I don't know if they included the do nothing option, but that's obvious what would happen there. But it was just whether that would be something worth just at least discussing as an option because of the benefit it may help. It could very well eliminate some of the complaints in terms of odor and this kind of thing. It might do that kind of thing, but it just depends on basically, again, returning things to the natural state and allowing that natural state to function to the benefit of water quality and also to some extent wetland habitat. So it's a big, it's not a small thing, but it's something to I think about.
Mill Pond would become Mill Bog.
Or mill, yeah, or whatever, marsh or whatever.
Mill Marsh,
Yeah.
right, exactly. I am sure the community would have, definitely have input on that. I'm sorry, Doug Brown has left and doesn't, sir, are you from?
No.
Would you like to comment? Give your name, please.
Vernon Innes.
Say it again.
Vernon Innes.
Okay, Bernard?
I've been there for 32 years. And up until about 10 years ago, we never had a problem with Mill Pond.
Right.
And the cranberry growers used to actually take the weeds out of the dikes and remove the weeds and take them. And today what they're doing in the last 10 years, they cut the weeds and the weeds go back in the flow of water. And when the flow of water, they open the gates from after they flood it, and all the weeds go back into the pond. Now this is creating a problem. Now I've talked to Amber, and I've been up to several trips with Amber when she's taken the samples of the water, and she's saying the same thing. The problem, what you're saying, if you want to go back to the original, it's not going to make any difference because you still have a problem. You have a problem with the cranberry bogs because he's not getting rid of the weeds and the seeds and everything else coming through the water. So you haven't solved anything. Amber says you have to put a gate or some kind of barrier to collect the weeds, but then you have to have somebody clean the gate out every once in a while. So, I mean, one thing, but if you go back to the original idea of removing the weeds before he cuts the weeds and get them out, now you're on a successful area where you're going to create something, and then you can clean the pond. If you don't start from that point, you're not going to clean anything. One of the game warden, Mr. Souza, years ago, he used to actually go down there and used to actually extract the weeds out of the pond on his own until the EPA decided you have to get a permit for this stuff. Well, I'm sorry, if you can extract the weeds out, and once the weeds are out, the pond is back to a pond, and you're not going to get the odors. But if you don't start with the cranberry bogs,
Yes.
you don't have anything.
Yes, I think that came through in the report, that the very first step really is to work with the cranberry grower.
And you have to remove the weeds. You just can't cut the weeds and let them go back in the water.
Okay.
You haven't created it, you haven't solved any problem.
Thank you very much for coming.
I think that's a good observation. I think that is, as I mentioned, and I think my comment to you, Virginia, that would be the first thing, would be part of the
Yes.
process. And I think that's a very good observation to get the weeds out. And then we could see, work upstream, do as much as possible, see what happens. And if it solves the problem, then it solves the problem.
Yeah, we never had a problem up until that point.
Right, I understand.
It's all about extracting the weeds instead of cutting the weeds and letting them go back and flow in the water.
Okay,
Okay.
all right, well.
That's a good point.
That's very good. And we will certainly forward that when we forward. I need a motion to approve this report so they can finalize it.
I'll make a motion to approve the report as submitted.
Second?
All right, all those in favor?
Wait
Aye.
for the discussion. We're sending comments along with,
We'll send a cover letter saying the comment you've raised, the comment
Okay.
Mr. Ines, thank you, Mr. Ines.
Okay.
We'll send that, we'll
Okay.
send those things along.
all right.
Okay, thank you very much. Okay, so moved and seconded, and we said all in favor.
Aye.
Aye. All right, next on the agenda is what is being called at this point a master schedule. I do have a copy here for the press, and because it'll be a little easier for you to follow, and if you would give one to the League Observer, that would also be helpful. Just because there are a lot of things coming up, it seemed to make sense to try and put everything down in some sort of a timeline, and that the committee should discuss it, and it's labeled draft, and it's going to stay draft, it's a work in progress, and we will tweak it as we go along. I started by listing what we had accomplished, starting when the original environmental notification form was filed to upgrade the plant, which was in 2002. But the work that this committee is doing really started in 2009, when we had the needs analysis and alternatives analysis for Little Pond, Great Pond, Green Pond, Bournes Pond, and all of the Wacoit Bay area. And then West Falmouth Harbor got added in because of that's where the discharge from the plant goes. And so there is a certain pattern of how the state works with the community to develop a draft plan, usually called a comprehensive wastewater management plan, and that goes through a review process and a feedback process, and then a subsequent process that leads to a final CWMP. And then the town begins to implement what has been agreed to. And fitting in with that are town meeting issues, ballot questions, bond issues, and a financial plan. So we've done that for one watershed, which is the Little Pond watershed, and we're now beginning to focus on the Great Pond watershed. So there will be some familiarity of the same sort of pattern of planning and votes. But we're also required to, under this particular comprehensive plan, to report on everything. So that is within the initial CWMP. So it's all the other watersheds, Green, Bournes, Pond, Wacoit, and so on and so forth. So it's a big task, and we're calling that an update. It is filed, it is due to be filed, and it's a legal deadline, December 31st, 2019. We are now developing pieces of that document. The GHD is working with the Department of Public Works on various kinds of sewering issues, and also all options for discharge sites. This committee has been following through on the various demonstration projects, and so there's an entire chapter that's a report on the demonstration projects. And then we've begun this public discussion specifically about the Great Pond watershed. There was a subset of that, which was Perch Pond, which was a discussion with the selectmen just this past Monday, along with the Conservation Commission and members of the public. And if you remember, Matt Sleeper was here, a resident of Perch Pond. So that's going to clearly have a section in this update. I just thought it was important for the committee to sort of be aware of when things sort of are due, because we're also working on a second comprehensive wastewater plan, and that's the Oyster Pond. So that's a lot to have on your plate at once. And so this is just a first cut draft of when I think these things might actually sort of roll out in terms of a workload. And I'm interested in input, particularly from Steve, because you're working on the Oyster Pond. And are you on that working group too? Yes, and John. So as it is now, I just put in here, just for discussion purposes, whether the first draft of the draft, Oyster Pond CWMP, do you think would be ready for the committee to review as a whole document in the November, December timeframe? Just curious as to whether your impression of that.
I don't know, what do you think, John? I mean,
I think we're not far from being able
Right.
to do that. I mean, I think it
I mean, I'd
depends
wanna
on
ask
when we ask
Leonard.
Wright Pierce to sort of finalize things. We have that fairly extensive management plan that we
Yes.
need to work our way through. We had those issues with phasing that we still haven't come to grips with. But I think that's, a meeting or two away, we can get that finalized. And I think that lets us see a roadmap for how we could put that CWMP together for Oyster Pond.
Yeah. Because it is a significantly smaller watershed, and clearly we don't have as many options to discuss and weigh. It's gonna be either sewers or IAs. I'm hoping that can sort of be our winter work, because there's no question that by very early spring, the CWMP for Great Green, Porns, and so on, that GHD will have begun to produce that document, and that one is gonna take focus, and so that would be sort of our early spring into summer workload.
I think it depends on how definitive this draft has to be, because basically, it's a matter of waiting to find out what DEP says about our management plan for IAs and what the story is on effluent disposal sites.
If I can take those in two pieces, what DEP says about your management plan. It's my sense, and maybe I'm wrong, that this document, this draft CWMP, is actually the vehicle that we're going to use to get a real response from them. They've been received pieces.
Right,
They've received
yeah.
pieces, but now they would receive the whole picture with a recommended.
And they could act on it
And
officially.
they could act on it officially, they could comment on it officially, they could say, these are the areas we think you haven't considered. And that's why there's always a draft CWMP before there's a final. It's so that all of the various agencies that would ever be affected by your plan get to comment under a formal process. Ron?
I was just going to say that I think the point you raised is an important point in terms of the approach to draft or finalizing. And that concerns which way we go. Okay, or the project.
Are you talking about Oyster Pond here?
Oyster Pond, yeah, that's what we're talking about.
Okay.
now. So with Oyster Pond, as you said, it could be IAs, possibly, or it could be the sewer, depending on, as Steve said, the discharge limits,
Yeah,
right?
and we'll get back to that in a minute.
So if we it's hard, for me at this point, it seems hard to finalize a plan until we know what we're gonna do, actually. And finally, even create a draft plan until we know, unless it says in there that we're still evaluating.
It will.
It will,
Oh,
it
will.
will.
Okay.
It won't decide.
Okay,
It
so
will say that
That's right.
IAs are our preferred plan and sewers are the backup.
So this would then be, the CWMP would be more like our previous CWMP, and there'd be a targeted watershed plan that would be
Yes.
done subsequent to that.
That's right.
So it all sort of lays out the options, and then later we specify.
Right.
Okay.
In a way, it's like the old report with some of the columns whited out.
Fair enough.
No, I
Very
understand.
easy to do with the word process.
Yeah, right. I know, but I'm just saying, though, that, it sounds like final plan. It means, okay, here's what we're gonna do, but this is more of a scope, a final scope of what,
Right.
of the options, okay?
That's right.
Yeah.
And then talking about the discharge piece specifically, there'll be a whole chapter in the townwide CWMP update that is devoted just to discharge options, the degree to which the town has investigated A, B, not C, so on. And so there are at least a half a dozen options, and then there's going to need to be some input and narrowing of those options. The degree to which the DPW does that, or whether this committee weighs in, I don't at this point know. I mean, those options include going to the base is still on there. Then there are various sites in the town, and then there's outfall, and then the outfall can be in various places. So there's quite a range,
Right,
and
and-
all of those will have to be laid out in this update, and then a commentary, usually from the engineers, of the pros and cons of each, feasibility, does the town own the property, so on and so forth, things like that.
So GHD is gonna do they're doing that.
They're
that's
tasked with doing
that major,
that
that's a
piece.
big piece of, that's
Yeah.
a big piece.
Yeah, but that ultimately ties into what ultimately happens in Oyster Pond. And the town, as meaning the Board of Selectmen and maybe town meeting, ultimately will need to have some specific votes and take some specific choices as to what path they're gonna follow for a discharge site, for anything that hooks up to the plant.
So the one thing that, you know, it's perfectly logical, and it's the way I think we need to, the process should go forward. But we got, as we heard from the neighborhood, they're getting a little impatient, you know, but I think it's good
You're talking
to-
about Perch Pond?
No, I'm talking about Oyster Pond.
Oyster
They
Pond.
want to know what to do. Should we go and do it, or they're suddenly going to put in a sewer and we have to pay again, or what are we going to do?
Right.
So that is, because they were speaking to that effect, we want to do something now.
Yes.
But the thing is that we are where we are.
Right.
And we have to get to where we're going to be as fast as possible.
That's correct.
Right.
Yes.
So, okay.
But, I
Right.
mean, there are other important aspects, but I didn't know how far off you wanted to get into Oyster Pond at this point, because you're mainly just talking about the schedule.
We,
Well, this is part of it. but, yeah.
I thought it was really important for us to have this kind of conversation.
Oh, well, then let
yes.
me speak,
Go right ahead.
everything Ron said I agree with.
Right,
The other way of looking at it is, Eric's thinking is, and I disagree with some of the details, but I agree with it in principle, that clearly IAs are going to be a valuable choice, if not the only choice, in many areas of town. And the Oyster Pond project might be the pilot testing of those to get general approval for 2 or more systems. And there's risk with that. You have to admit that it's, if you already know the outcome of an experiment, why do an experiment? If you don't know the outcome, you've got to admit that you don't know the outcome.
right.
But that's one reason to do it early. The cash flow for the town is better, because even if they cost exactly the same, in the case of sewers, the town pays for the whole thing, and the residents reimburse them 70% over 30 years. If it's IAs, the the homeowner pays for the whole thing, and then the town reimburses them 30% immediately, and hopefully the homeowners have a 30-year interest-free mortgage to pay off their 70%. So the profit loss is exactly the same for both parties, but the cash flow is different because the town doesn't have to go out and bond the whole thing. So Eric thought the money might be available before 2025, which is consistent with the idea of using it as a pilot project for other areas.
Well, another, I think, pardon me, it's okay.
No, go ahead.
Yeah, another dimension too is that there are probably a number of areas in the watershed where it won't be reasonable to extend a sewer pipe maybe, right?
Absolutely.
And if those areas could be, because that would give us an immediate action point for IAs, where those areas could be.
But no, I disagree with that. I mean,
Okay.
the plan for the sewers involves, by definition, extending the sewer pipe to enough areas to meet the TMDL.
Well,
You're talking about Oyster Pond, he's moved on to other watersheds.
No, I'm talking about Oyster Pond.
Oh, you are talking
Yeah, I'm
about
talking about Oyster Pond, that there might be some areas down Ransom Road there that there are few properties to extend a pipe down there may not make sense.
There are enough properties within pipe range that the sewer
Could do it.
comes out
Okay, so that,
cheaper than IAs
okay, all
in
right.
an area that's favorable, that's not
Yeah,
so
yeah.
favorable to sewers. I mean, it's sort of,
Okay,
I think that the scheduling issue, though, is pretty simple. As our preferred solution in December of 19, we say, we prefer to do this with IAs. This is how we propose to do it. If the state says, we're sorry, that doesn't work, their fallback position is always sewer.
Right.
Right.
So
Which
that's
fa-
our second choice. So
Okay.
it makes it a pretty
Yeah.
easy decision to make how we lay out that CWMP.
that's
Okay.
right.
And then that becomes a certainty that gets folded into the larger CWMP that we're working on. That we'll have to have enough capacity for not only the Great Pond watershed piece that's to be sewered, but also the Oyster Pond piece that's to be
But the
sewered.
Oyster Pond is a drop in the bucket
Ex-
compared to these other big
But
places.
It is, but every gallon counts.
Right.
but it's also, I agree with Steve, though, that there is a cost, he says that sewers could be cheaper, okay? So basically, I don't think we're gonna, if it turns out if it's less costly to
Sure.
the homeowners, then it may override the IA systems, even if, so it's not like first and second, I think it's like we have
No,
two
but-
options.
But the reason
You have to
for
work 'em out.
stating it the other way is what
Yeah.
John was trying to say is, if you say to DEP that sewers are your first choice, they say, well, fine, get out of here, don't waste my time, go do
Right.
sewer.
Oh, I see.
And we never know what they
Right.
think of
And
IA.
That's right, so
If we say IAs,
IAs, they have
and
to
they
respond.
disapprove IAs,
I
well,
see,
that's
okay, all
a
right.
slap in the face, but one we needed and we really learned something.
Okay, we're gaming the
If
system,
they
it's
say,
okay.
if they say okay, then they've said okay to
I
both
get it.
things, and it's back in our court to decide.
Right.
Well, if we have to get approval for a large scale, relatively large scale IA area, to get that from the state, that would be useful. Whether we do it or not, that would be useful to get a go-ahead.
Feedback on that, yeah. Okay, well, this is, Matt.
What
sorry.
triggers a CWMP update?
A variety of things can trigger it. In this particular case, when the secretary issued its certificate for approving the last CWMP in 2014, they put a whole list of conditions on, and one was, you shall have 5 years to do your demonstration projects, and then you shall report to us what you've done.
Okay.
So that's what, and then they put this date, this
So
definite
we
date
won't
in.
know, this runs through 2030. We won't know if another CWMP update is needed before then until they review the
Oh, they-
2019.
Right, but
one.
there will be. Normally, both DEP and MEPA operate in 5-year, that's how they think, in 5-year. So there will be another one.
But it takes them 2 years to review it and,
It usually takes them a year.
okay.
It usually takes them a year. You know.
There will be
average.
another
Oh, there
update
will-
in
oh,
this window.
Absolutely, yes. Okay. All right, so that's it for the discussion. Reports of members and staff?
No, I'm not, no, I would just like to talk a little bit about the Great Pond.
Oh, sure.
Schedule, right, just for a
Okay.
moment. Now, we're talking about CWMP update, in a
Yes.
sense, right? It's not a TWMP, or.
No, it's not. No, that's a separate document that is
Okay.
subsequent.
Right, so in this document, although it says in here sewer, right?
Right.
There could be a PRB option, there could be an oyster option, but these are things, I think, that could be built in. There could even be an IA op, but the point is that it's not like we're setting a preference, but when we get down to the targeted watershed design, then it would be selected.
That's right.
The only other question I have, and maybe I can answer it myself, I guess, is that since we haven't finished Little Pond in terms of the models,
Right.
but maybe it's better, that maybe we should shift and try and do more there, or we say, okay, we've got this in essence, a demonstration going on, and we'll see how far we get, and then subsequently, in probably 2030 or something, well, he's talking about years, right, before, and talking about the TMDL and everything
Yeah.
in Little Pond. It may be a while before we'll know how much more needs to be done there. So it could be could be left as a future to complete that. And then we would continue to march east in a way, so.
all things
Yeah.
are could,
Yeah.
could be possible. I think the state is looking for, towns to move forward in a steady way. And so the reason I'm interested in their data through 2020, do we have an early indication, at least where we have short travel times, that the groundwater actually does begin to improve, in Mara Vista as an example.
I wouldn't expect that, because that slug of nitrate at the bottom of the deep part of the lens is going to skid up and come out at the surface. So it's gonna keep feeding.
For a while.
For a while,
Yeah.
yeah.
Yeah,
I
you're
would
right.
think so.
I think that's, so we may, the idea of
I don't
removing
think
it near
there's
the
gonna be a
shore.
quick indicator.
Okay.
Well, wait a minute.
And then you have to follow the pond health as well at the same
You-
time.
you do.
Because, yeah,
That's right.
there's
And-
quite a lot
and-
of nitrogen stored in the pond itself that's gonna need to be flushed out.
Good point.
But, John, you're right, that lower plume has been going through, is going through, and will continue to go through. But the upper plume will presumably end at some point, not right away, but in a couple of years. So that means, but what's going into the pond is the sum of those two, right? So the sum goes down. Does it go down enough to be statistically observable? I don't, does anybody know the answer to that?
That's why he wouldn't answer your question,
Yes.
rightfully so. I mean, no scientist in their right mind would answer your question. That was a trap by an engineer.
A TMD, well, he was asking about TMDL.
Yeah,
That
but
was right.
I,
Yeah, and when you
I
said
agree.
put an error bar on it, is 1,000% error bar work for you?
That's what I was thinking.
very good. Okay.
All right, thanks.
Obviously, anything with sewering is a lot of long-range planning, so the town will continue to work towards those possibilities. But getting results from Mara Vista definitely is going to be a factor.
So this project, I don't recall, it's
This project, USGS,
USGS, yeah, that just went on. Who's funding that?
they are through a SNEP grant, that's at Southeastern.
Oh, yeah, you said that at the beginning, yeah, okay.
Right,
I came
and-
in a little late, I heard that.
Yeah,
I didn't-
and they do have some other funding. And they have been trying to extend that out. EPA Region 1 is very interested in this, and so I think the likelihood of having follow-on funding is definitely a possibility.
That'd be a first.
Well,
And also,
and
push comes
also,
to shove, the town ought to.
push comes to shove, the town has a vested interest in this as well.
Right,
And
okay.
that's why
That
I
makes-
said, he doesn't have to do the full suite.
Right, we don't need all those assays.
No, we need sucrose and nitrate, total nitrogen, and, you'd
We don't
find out
even need
mostly.
sucrose, all we need
we-
is total nitrogen.
I understand. Sucrose is sort of like a X marks the spot.
Also, the contaminants of emerging concern, they're measuring, and so that would be that's another important element, because as I think Ray Jack has said a number of times, that that ultimately, those may be put under, not just nitrogen, put under control, and therefore, certain systems can't deal with that, and others can, and the sewer can, but others can't so much. So, anyway.
You mean the sewer does reduce it below parts per
yes.
trillion?
No, it
the
takes
sewer
it away.
can't, it just puts
Basically
it somewhere
eliminates
Takes
else.
it somewhere else, but then the plant, a central plant, can have a component added, maybe, that would capture that stuff.
Actually, early, just sort of preliminary results show that the plant actually processes it pretty well.
Like that, really? Okay, good.
Okay, moving on to reports of members and staff. Does anybody have anything?
Well, three of us were at a meeting on Monday night.
Sure, go ahead.
There was a joint meeting of the Board of Selectmen, our committee, and the Coastal Resilience Committee, and Conservation Commission, and I think that was it, right, pretty much.
The selectmen.
Selectmen were there, I say selectmen, yeah.
Right.
So, it was interesting, it was nice to have people out of different views coming, and a lot of interesting viewpoints presented that, were, in terms of moving forward. So I thought, I think that it was interesting, and one point that came up that I have subsequently spoken with Ray Jack about was the discussion about the Borns Pond inlet widening project. That I don't know if we've really discussed where things are right now, but from what I understand from him is that the bridge has basically been approved to be done. But now there's another element they're looking at, which is how to preserve the road. And that connects the Minot Road there,
Right.
that connects to the two ends of the bridge. And so they're looking at different elements of that in terms of the life expectancy of the road and whether it's therefore worth building a new bridge if there's an issue over the long-term aspect of the road there. It's unlikely that, it seems at this point unlikely that it would be abandoned, I think, by the town, but it depends. I mean, if we get, a large coastal storm, something significant happens, and then there's a concern about the future, we don't know what, but somebody, I guess the DEP is evaluating that element, and that decision will result in whether, I guess then the town will have to decide whether to proceed with the
Well,
inlet widening or not.
His assistant, whose name I never remember.
McConerty?
Peter McConerty.
Yeah.
McConerty, I think had a slip of the tongue. He made it sound, you can go watch the video and I think you'll find right. He implied just what you said, that gee, the road is maybe a problem and are we going to do it? So I went up to Ray Jack afterwards because McConerty had gone and I said, your assistant implied that you might not do the road and the bridge, because obviously if you do one, you
Yeah.
have to do the other one. And he's adamant, he said, no, we're doing it. He said he implied that McConerty misspoke or I misinterpreted him. And
Well,
in Ray
guys,
Jack's opinion,
We're
it's
doing
a done
both.
deal, we're doing both.
And-
It's just a question of exactly how you do the road and how you protect the
I-
beach.
Well, the main, sorry, I just want to ask something, that what he explained, what McConerty said too was that the state was checking it, okay, in terms of I'm not sure how the state could or intervene, because they already approved the inlet widening project, but if they have an issue over the life expectancy of the road, regardless of what groins or things that would be added, that would be, I'm just saying that it's not certain yet, a decision from, at least from the state side. And then he said that even then, let's say the state says, oh yeah, go ahead with it, well, the town still has to decide what it wants to do.
Well, it has to be permitted, and
Yeah.
permitting will involve the Corps of Engineers. And as we've found with the inlet widening, working through the Corps is long and tedious. We're nearly through. But there's always that open question. And my sense is Ray Jack intends to do the project, and at this point, I think he intends to do the project jointly. Because the road, for the road has to be closed for a year, so you might as well do all of the issues with the road at the same time. So that's where it stands. So that's the report that we had with the Board of Selectmen, and it was a very good exchange. I have one thing, just sort of a follow-up from our last meeting. I received an email from Pio Lombardo of Lombardo Associates. We had been talking, and what he zeroed in on from the enterprise report was a statement by Eric, and my name was also linked to it, that the various kinds of technologies we were looking at in the West Falmouth area were all in the pilot stage. And we were talking about meeting a standard of 10 milligrams per liter or less. And Pio's comment to me was, my system, which is the Nitrex system, is in the provisional stage. And so it's not accurate to say that all the available technologies are in the pilot stage. And so I just told him that I would make this clarification at the meeting. His system is in the provisional stage to meet 19 milligrams per liter. We were talking about 10 milligrams per liter, so that's the distinction. PO says, well, my system is now meeting 3 milligrams per liter. Well, that's wonderful news, but, you know, I don't know that that's totally official yet. So anyway, I'm just making that clarification.
There's no standard of 10 milligrams per liter,
No,
right?
at
The
this
only thing
point.
that he could possibly be
Be.
in competition to meet is 19.
Is
right?
19,
Is
that's
That's the
correct.
classification.
He could have 3 on a smaller number of systems. And he could say, I'm meeting 3, but not have provisional in 3. I think that's what you're saying.
Well,
Whatever, yeah.
No, he could have
I
3 and the
am
state will say
simply
that he'll
reporting
lump,
that
they'll
he
lump.
wanted it clarified that
Right,
his system is provisional,
But,
not pilot.
I don't remember the exact wording that Eric used, okay,
I don't either.
exactly. But was he talking about that all of the systems, the actual IA systems in West Falmouth are in pilot?
Yes,
Not that
that's what Eric,
not that all
System-
systems are in pilot.
that's correct.
I think it was more that was, what we were doing was testing systems that were in a pilot
And
stage.
PO doesn't have a system in West Falmouth.
No,
No, that's what I mean,
he
yeah, exactly.
did
yeah.
market it and no one chose it, so
Yeah.
that's
Right.
the way it is.
Yeah, no, but I mean is that one isn't there, yeah,
Yeah.
exactly, so.
Right. Okay, vote minutes of prior meetings. We have August 30th, 2018. Any additions or corrections? Motion?
Move to accept?
Okay,
Second.
all those in favor?
Aye.
And then the minutes of September 6th. Any additions?
I'll
Motion?
move we accept the minutes of September 6th.
Okay,
Second.
all right. All those in favor?
Aye.
Aye. Okay. Scheduled for the next meetings, October 4th would be our next regular meeting at 3:30. Eric, I will not be at that meeting. Eric Turkington will be back on the 1st, and I just mentioned that, so it's possible we might not have a meeting.
Well, I won't be back till the 6th.
You won't be out, okay, so you will be out also.
Something on the 4th for me too, but
And, okay.
I'm not sure what it is.
If you can let me know, will,
Okay, I'll let you
okay.
know, definitely. yeah.
but we definitely will have one on the 18th.
Did you already do reports of members and staff? or-
You can bring up anything you want.
Oh, I mean, this is just an anecdote. It was on the radio this morning, and you probably know far more about this than I do, but I thought it was relevant to the committee. It's on the radio this morning that apparently Mashpee is going through a big town decision about how many hundreds of millions to spend and whether to use shellfish.
Really?
And they were making statements that I won't quote because I'll probably get them wrong, about whether shellfish work or not, or whether they should use them. But it sounded like the implication of the news story, which could have been wrong, could have been misinterpreted by me, was that they're at a rather late state, I mean, a town meeting kind of stage of making this decision. And so whether they have information from DEP or whoever as to whether shellfish are given credit, we should find out, right?
Well,
If we don't already know.
I can give, I mean, if you read their report, okay, this is a bit, I forgot how many, a few years ago. They have come up with a plan that looks like the Oyster Pond plan. We've got basically two pillars, okay? One is all sewering, which was $360 million. And then there was the sewering with shellfish, and that brought it down to about $220 million or something like this. The shellfish were to reduce it. And so they've already invested in starting the shellfish activity and that's the only thing they've done so far in Mashpee. And there was a recent report that said that I think that Brian Howes was also was quoted in about the fact that like McCoy Bay system's getting worse over time. But what Rick York said, also quoted in the article, was that in the areas where they had implemented the shellfish, things had improved. So it's hard to know. This plan has been approved by DEP. It doesn't mean it's a they didn't approve the outcome, or they didn't certify any outcome, but they said yes, that they could proceed and to see how well they can do with the shellfish. So I don't know, if it's a town meeting thing, the last time they voted, I think it was like $250,000 to get the shellfish activity underway with regard to water quality improvement. And maybe there's another consideration now coming up. And when Andrew Gottlieb was here, I asked him specifically, is DEP going to allow you to really give you credit for the shellfish? And his response was that it doesn't matter that much now, that they're planning to go ahead with it to see what the outcome can be. He was very, very strong. Now, things change, but that's basically the element. I haven't seen the report you talked about, Steve, but.
I just heard it on the radio. so
Oh, okay.
I could have gotten
Well,
it
it could be
wrong.
the next tranche is being considered for shellfish, which might not be but they have a big program that's been quantified by our consultant. The same consultant we use, GHD, it's their report that identifies this. And they say it's a conservative estimate, because it's only nitrogen that would be assimilated into growth and not any associated denitrification from the shellfish. So, yeah.
My addition to that would be that when DEP approved their final CWMP, it basically said, okay, Mashpee, go ahead and try shellfish. But if you don't meet the TMDL, you have a sewer plan, which is also in this same document, which is your backup plan
Right.
for meeting the TMDL. So it's a sort of wait and see, and obviously, to implement anything, you have to have some funding. So thanks, I didn't realize this was on their fall town meeting. but-
I'm not sure of any
You're
of
not-
this.
Okay.
But,
but you-
but the other thing is that of the sewer investment, all right, let's say it's 220, 240
Whatever.
million, some sewering needs, to be a good part, a good
There's
chunk of sewering would need to be done.
Yes.
If the shellfish met the target that they
Yeah.
estimated. So it isn't like one or the other, it's probably both.
It's both.
At least, if not, yes. But they want to see really what the shellfish will do first before they start doing it. But they may change now. They may be saying, okay, well, we need to do this area or something. Yeah.
Right.
So really, when DEP approves these plans, they're essentially, all they're saying is, we believe this is a good faith plan. You're not,
Right, they're not,
you're not kidding us. You're not saying you're gonna solve the problem with pinwheels and lollipops. This is something that actually makes reasonable technical sense. But the responsibility is still yours.
Right.
It's
If
a
it
wait and
doesn't
see.
work, hey, get ready to build more sewers.
correct.
I mean, we went through this ourselves over the West Falmouth treatment plant, our wastewater treatment plant, in that within 10 years, we're supposed to see it, at least in the wells at the shoreline, some impact. And we're not seeing that yet after 13 years. So it's like, okay, do it, but now we've got this. But then we did talk about build out and things that may be contributing from other aspects, so. Anyway.
Will anybody entertain a motion to adjourn?
Absolutely, I was just about to ask you.
I'll second.
Second, all right.
Okay, I'm ready to go.
All those in favor?
Aye.
Aye. Thank you very much.
Thank you.